Let's get the ball rolling. Question number 1, solve the inequality. And we have a quadratic part on the left side and linear part on the right side. Whenever you have such a situation, first of all, we need to merge them. So we will open the left side first. So it will become x squared minus 2x plus 5x minus 10 greater than 3x plus 6. And now collect everything to the left side. So x squared minus 2x plus 5x minus 10 minus 3x minus 6 greater than 0. And this is the purpose. We want to make it as compared to 0. In this case, it is greater than 0 means we want this part to be positive. Greater than 0 means anything more than 0, which is positive. All right, let's simplify this. X squared, this will be 3x and 3. Oh, x is gone. All right, yeah. Minus 16 greater than 0. And it is a format of a square minus b square, this one. So we know if we factor this, it becomes a plus b, a minus b. That's a very popular identity. So that's what I will do here. Square root of 16 is 4. So x plus 4, x minus 4 greater than 0. So we get two roots now. From this, we get x plus 4 equal to 0, so that x is equal to minus 4. Here we get x minus 4 equal to 0, x is equal to positive 4. So we have these two roots, and now we have to solve the inequality. Many of the students I've seen, they stop here. They find the roots and these are the answers. Can you see? Equal sign? No. In inequality, we get a range. We don't stop here. So we should draw a number line where we write minus 4 on one side and 4 on one side accordingly, because these are two roots. Our answer will be either in this range, less than minus 4, x is less than minus 4, or in this range, which is between minus 4 and positive 4. And third option is x is greater than 4, which is this. Now, how do we decide which one is the right answer? So we do what? We substitute any random number which is less than minus 4 into our inequality and see if it is giving us the required number, which is a positive number. So let's take a number here. Let's say minus 5. So let's put minus 5 here. So minus 5 plus 4 is minus 1 multiplied by minus 4. Minus 5 minus 4 will be minus 9. And it gives us positive 9. Yes, it is more than 0. This is one of the solutions, this inequality. Okay. Second, take a number between minus 4 and 4. 0 is the best option. Let's put 0 again here. 0 plus 4 is 4, positive 4. 0 minus 4 is negative 4. It is negative 16, which is not greater than 0. So no, this is not our solution. Ignore it. Now, greater than 4. Let me take, okay, this time let me take very close to 4, say 4.1. You might be thinking, why I'm taking integers all the time? Let's take a decimal number this time, 4.1. So again, same, I use 4.1 plus 4, 8.1. And 4.1 minus 4, 0.1. Both are positive. I'm interested in sign, not in the number. So yes, it is positive, and that is also an answer. So this is an answer. So we have these two answers. X is less than negative 4. X is greater than 4. Number 2. Okay. Solve the following simultaneous equations. Right. So first one is this, and second one is this. We can see the second one is y plus 3x equal to 11. And that gives us a chance to isolate y, right? And now we can substitute this value of y in the first one. So I'm using the substitution method of solving simultaneous equations. So x was x in the first equation multiplied by y, and now y we have 11 minus 3x plus x squared equal to 15. The first question was an inequality. This is an equation. We'll get exact answer for this. So let's open the bracket here. 11x minus 3x square plus x square minus 15 equal to 0. To give it a quadratic look, we will write squares first. So minus 2x square plus 11x minus 15 equal to 0. And now we can factor this to get our answer. So we have 30 and 6 and 5 is 30. So I'll factor this like this. If you don't know how to factor, you must scan my channel and see how to factor a quadratic function, or just use your calculator to solve this. So I'm doing this. Let me give you a small hint. Minus 2 and minus 15, I multiplied it, was plus 30. I factored plus 30 somehow so that I get 11 as a sum of the two factors. So 6 times 5 is 30 and 6 plus 5 is 11. So that's what I'm going to write here. 6x plus 5x minus 15 equal to 0. So minus 2x, let's take it, oh, it was square. 2x, x minus 3 plus 5x minus 3 equal to 0. So we get 5 minus 2x. Let me write this way. And x minus 3 was in both. These are the factors and they will give us the solution now. This one gives us 5 minus 2x equal to 0, x minus 3 equal to 0, right? And when 5 goes to the other side, it becomes, so x equal to positive 5 over 2 because negative and negative cancel out, 5 over 2. This gives us x equal to 3. But we have to solve the simultaneous equations completely. So we have to get the counterparts now, means y. And let's use the one we did for y. This was the isolation, y equal to 11 minus 3x. This is what we will use to get y in both cases. So y equal to 11 minus 3x. So let's do this one first. Y equal to 11 minus 3 times 5 over 2. So y equal to 11 minus 15 over 2. So 11 times 2 is 22 minus 15 is 7 over 2. So the first answer is x equal to 5 over 2 we got earlier. Now we got y equal to 7 over 2. Second, y equal to 11 minus 3 times, what was the value of 3? 3. So y equal to 11 minus 9, which is 2. Second answer, x equal to 3, y equal to 2. Let's move on to the next one. A curve has an equation of this given here. Okay, show that the exact value of dy over dx at point x equal to pi by 6 is this. All right. So let's find dy over dx. So dy over dx will be, we will use quotient rule in this. So the denominator will get squared. And then we will write the same denominator first, and then we will differentiate 2 plus sine 3x, okay? Minus, we will write the numerator as it is, but we will differentiate x plus 1, denominator. Okay, which is x plus 1 will be x plus 1. 2 plus sine 3x. The differentiation of 2 is 0, so I'm not going to look at this. Differentiation of sine 3x will be 3 cos 3x. Cos 3x multiplied by the differentiation of the angle 3. All right, minus 2 plus sine 3x and differentiation of x plus 1 is just 1 over x plus 1 square. Usually, I would simplify this further, take something common, factor the numerator, right? But since they have given us a value of x, let's substitute pi by 6 and straight away we'll get some answer. Okay? So pi by 6 plus 1. This will be 3 cos 3 pi by 6. 3 and 6 cancel out, pi by 2 only. Minus 2 minus, this minus will change both the signs. Sine 3 pi by 6. Again 3 and 6 cancel. It is pi by 2 over pi by 6 plus 1 square. All right. So here we get what? Cos pi by 2 is 0. So this whole thing becomes 0. So we are left with this minus 2 minus sin pi by 2 is 1. All right. Pi by 6 plus 1 square, which is minus 3 over pi by 6 plus 1. And I think it is matching with the expression they had asked us, k x plus 1, where k is an integer. So we got it. Let's see what the next part talks about. Find the equation of the normal to the curve where x is equal to 0, not pi by 6. That means, what can we do? Let me erase this part. And in place of pi by 6, let me write 0 now. So dy over dx at x equal to 0. It will be 0 plus 1, 3 cos 3 times 0 will be 0, minus 2 plus sine 3 times 0 is 0 times 1. No need to write 1. Okay, and here it will be 0 plus 1 square. So 1 is 1. Okay, 3 cos 0. Cos 0 is 1. So we get 3 here. Nothing else. 0 plus 1 times 3 is 3. Minus 2 plus sine 0. Sine 0 is 0. So most of this is becoming simpler. So 1 square will be 1. So 3 minus 2, 1 over 1, which is 1. If you are not sure what was done here, just plug everything x equal to 0 in your calculator and this will give you 1 for sure. Now, this is the gradient of tangent, but they are asking the equation of the normal. Reciprocate this to get the equation of normal. So y minus y1 equal to minus 1 over m. X minus x1. This is how we find the equation of normal, where m is dy over dx, the gradient of the tangent. So we know x1 is 0. We know that m is 1. We don't need to know x, which is a general x. We don't need to know y, but this y1, the y counterpart of x is needed for the curves. Let's go to our equation. Our equation was this. So let's find y from here. 2 plus sine 3 times 0, 0 over 0 plus 1, which will be 2 plus 0, 2 over 1, 2. So when x is 0, y is 2. We can put that y here. And now we are ready with the equation y minus 2 equal to minus 1 over 1 times x minus x. And let's collect everything to the left side. Y plus x minus 2 equal to 0. This is the equation of the normal. All right, let's move on to the next challenge, which is question number 4. Find the rational values a and b such that this is equal to 1. Whenever we have such a situation, we should rationalize the denominator first. So a over square root 5 plus 2, we can rationalize the denominator by multiplying by the conjugate of the denominator, which is square root 5 minus 2, up and down, both. We can't multiply only one because actually we are multiplying with 1. Simply multiply this one also by the conjugate, which is square root 5 plus 2 and square root 5 plus 2. We can see the denominator becomes same for both. So we can combine them and it is equal to 1. That's what they're saying. So we know the identity a plus b, a minus b equal to a square minus b square. We did the same in one of the earlier questions, reverse way, where we converted a square minus b square into a plus b, a minus b. Right? Same thing we're going to do here. We are going to do the reverse. Now we'll write a square minus b square. So it will be square of square root 5 minus b squared, square of 2, straight away. If you are not aware how to do this, then you can individually multiply, you'll get the same answer. Now, here it becomes a square root 5 minus 2a. If I multiply a with both of them, plus b square root 5 plus 2b equal to 1. Let's simplify this first, okay? So we can write a plus b square root 5. I factored square root 5 out of these two, and here we can write plus rather 2. Take 2 commons and it will become b minus a equal to 1, and both of them have same denominator, which is 5 square. Square root 5 square will be 5 because square root and square cancel, minus 2 square is 4. So we have rationalized the denominator. So a plus b square root 5 plus 2b minus a equal to 1. I'm not writing the denominator anymore because 5 minus 4 is 1, divided by 1 does not make any difference. Now, if you look at these two, can I say like this? Can I write this as 1 plus 0 square root 5? There's a special reason behind that. Because square root 5 will not become a complete integer by adding something. That means this a plus b is equal to 0. And a complete number like this will never become a surd. So that means 2b minus a is definitely equal to 1. So I compared the integer parts, which was this, with integer, and surd part with the surd. They don't mix up once they are simplified. So now we got this simultaneous equations. So I can write here b equal to minus a and substitute it here. 2b, b is minus a, and minus a equal to 1. That becomes minus 2a times 2 minus 4a equal to 1. A equal to negative 1 over 4. And because b is negative a, b will become positive 1 over 4. All right, what do they have for us now? Bring it on. It is given that y equal to 3 tan square x, and it is between 0 and 360 degrees, okay? Show that dy over dx is this, where m is an integer, we have to find that integer. All right, so dy over dx will be the differentiation of 3 tan square x. So tan square x is the square of tan. Whenever we have power of function, it is used just like a normal power rule first. What I mean is this: 3 is a constant, don't touch it. Tan square x, bring that 2 in front and bring down the exponent of tan x by 1, which is just tan x, right? This is called power of function rule. But in power of function rule, we further multiply the whole differentiation by the differentiation of the one which had power. What had power in this? Tan square x. Square has been taken care of. The base which had this exponent, that is differentiated next. And differentiation of tan x is secant square x. All right. And further, we have to differentiate the angle. And angle is just x, so its differentiation will be 1. All of them are multiplied. So we get what? 6 tan x secant square x. So m is 6. What's next? This is next. Find all values of x such that dy over dx is 3 cosecant secant x cosecant x. All right. They're trying to play with our emotions. Now they have introduced cosecant x. So we know this was dy over dx, right? This one. So now we can equate them. 6 tan x secant square x is equal to 3 secant x cosecant x. This is what they're saying. Now, we could have cancelled this 2 with secant here and we would have reduced it. But never ever do that. Do not cancel things on both sides of an equal mark. Why? Because we will lose one answer because of that. What should you do instead? Bring everything to the left side. So 6 tan x secant square x minus 3 secant x cosecant x equal to 0. Now, we should factor these two somehow. The problem here is that we have secant square x here, secant x here, but cosecant and tan x, there's nothing else is common. So let's convert everything to sine and cos so that we get a combination of sine and cos, and all of them can be expressed as a sine or cos. So let's do it. 6 sine x over cos x, and this will be 1 over cos square x minus 1 over cos x, 1 over sine x equal to 0. Do we see something in common now? Okay, we can see cos x, and nothing else. All right. So 1 over cos x is common here, and 3 can also be written 3. Let's say 3, because 6 and 3 will have 3 in common. So we're left here with 2 sine x over cos square x minus 3 is out, cos x is out, 1 over sine x equal to 0. Now, this can be equal to 0. 3 over cos x equal to 0, right? So that means if cos x goes there, it becomes 0. 3 is equal to 0, which is not possible at all, right? 3 cannot be equal to 0. So this part is not giving us any solution. Let's go to the rest of it, which is this. Here, we can write 2 sine x over cos square x minus 1 over sine x equal to 0. Let's bring this to the right side. We will not cancel it, but we can cross multiply. So 2 sine x over cos square x equal to 1 over sine x. Now cross multiply. So what do we get? Let's do it here. 2 sine square x. Yes, sine x multiplied by sine x. Sine square x equal to cos square x over, let's write cos square x here only, and equal to 1. And we get here simply 2 tan square x equal to 1. Tan square x equal to 1 over 2, and square root both sides, we get tan x equal to plus and minus 1 over square root 2. And now this becomes our simplest possible expression, and we will just find angles because of this. For that, I'll have to go to a space where I can cleanly do this. Okay. So it is tan x equal to plus and minus 1 over square root 2. X becomes either tan inverse 1 over square root 2 or tan inverse 1 over minus 1 over square root 2, right? Our domain given was 0 to 360 degree. That means we'll have all 4 quadrants because it is positive and negative in all 4. So let's focus on the positive first. Tan inverse 1 over square root 2. What angle does it give us? I will use my calculator to do this. And by the time I find it, please subscribe to this channel, like and share this video with your friends so that everybody gets benefited. They know the approaches to solve questions, and I'm motivated to make even more videos for you. So I got here x equal to 35.3 degrees. So it is positive here. So this is the first answer, 35. 0.3 degrees itself. That is the first answer. Let's call it x1. x2, tan is positive in this quadrant, so this will be 35.3, right? But our angle, which will be right, will be this one. So it will be 180 plus 35.3, which will be 230, 15.3 degrees. Let's go to the third angle, which is, this is 35.3. So the angle will be from here till here. So x3 for this negative, okay, because in this quadrant tan is negative, will be 180 minus 35.3, which will be 144.7 degrees. And the fourth answer will be in the fourth quadrant, 35.3 degrees here. So we start from here and reach here, which is 360 minus 35.3 degrees. So it will be 324.7 degrees. These are the four solutions of the given equation. Question 6. Find the values of m for which the line y equal to mx minus 2 does not touch this quadratic function. So basically they're asking that if this is a curve, the line goes far away from the curve, it does not even touch it or cross it, right? To start such a question, we should assume they are actually crossing. So if they are crossing, the y value of the curve and y value of the line will be same at the point of intersection. So we will equate the two. So m plus 1 x square plus 8x plus 1, that is curve's equation, will be equal to mx minus 2 because both are equal to y. And now let's make this one quadratic expression. So m plus 1 x square plus 8x, and let me write minus mx after that, plus 1, and let me write plus 2 after that. This minus 2 will become plus 2. So m plus 1 x square plus 8 minus m x, right? Both of them have x common, so I took it out, plus 3 equal to 0. And now we will use discriminant b square minus 4ac to ensure that the two graphs do not intersect. And for that, b square minus 4ac should be less than 0. And this is a for us, this is b, and this is c. So we'll substitute their values and find the values for which they will not intersect. So b square, 8 minus m square, plus, not plus, minus 4 a c should be less than 0. And now we can continue. So 8 minus m whole square will be 64 plus m square minus 16m. Yeah, I use this identity, a minus b whole square equal to a square plus b square minus 2ab. So directly I use them. Minus 4 times 3 is 12, and 12 times m will be 12m, and 12 times 1 will be 12, but because of this minus it will become negative 12. And now we get a clearer quadratic inequality. M square, and this becomes minus 28m, and 64 minus 12 will be 52. Alright, and now you can use your calculators to find the values of m. I'm factoring this one. You can also use quadratic formula again in this, but full quadratic formula, not the discriminant part. B square minus 4ac. There are so many ways of finding the solution of such an quadratic equation, but this is inequality. We will get roots first and then we will use roots. Okay, so this will also give you roots, Factoring will also give you roots, and your calculators will also give you roots. I'm factoring it. So m square minus 26 minus 2m plus 52 less than 0. M, this was 26m, okay, minus 26 minus 2m minus 26. So if I factor this, I get m minus 2, m minus 26 less than 0. And the roots given by this one is m equal to 2. The root given by this is m equal to 26. And now, like we did earlier in this paper, we'll write them on a number line, 2 here, 26 here, and we will see where do they fulfill this condition of being less than 0. So let's take a number less than 2, and 0 is the best. So if I put 0 in this, what do I get? 0 minus 2. Minus 2. 0 minus 26 is minus 26. Together they are 52 positive. We want negative. That means this is not our range of answers. What about this? Between 2 and 26. Let me use an easy one. 10. Yeah, 10 is between 2 and 26. So 10 minus 2 is 8. And 10 minus 26 is minus 16. We can see this is positive, this is negative. Their answer will be negative, which will be less than 0. Yes, this is our range of answers. And anything more than 26, I can use 100. Let's use 100. 100 is more than 26. Yeah. So 100 minus 2 and 100 minus 26. 100 minus 2 is 98. Multiplied by 100 minus 26, 74. And there is no need to multiply. We can see both of them are positive. We will get a positive answer which is not less than 0. That means this is also not the answer. Final answer for this particular inequality is that m is between 2 and 26 but not equal. Okay, this is the final answer. Let's see what were they asking in the question. Find the values of m, and the values of m are any number between 2 and 26, both excluded. Let's go to the next one. Use logarithms to solve the following equation. Okay, let's copy the equation first. 5 to the power x minus 2 equal to 3 times 2 to the power 2x plus 3. So whenever we have exponent x of certain constant, we should first separate the x from other exponents. So this minus 2 must go, this plus 3 must go, this 2 should also go. So let's separate this one first. So since this is a subtracting exponent, we can write this as 5 to the power x divided by 5 to the power 2. Yeah, then only the exponents subtract if the bases are divided. Similarly here, 3 times 2 to the power 2x multiplied by 2 to the power 3. So because they're adding, they multiply. Because they're subtracting, they divide. Okay, so it is 25. Let's bring this 25 here. So it becomes what? 5 to the power x equal to 25 times 3 times 2 to the power 2 to the power x. Let's do this way, okay? And there's a purpose behind that. I'll tell you why. And 2 cube is 8. So 25 times 8 is 200 times 3, 600. 5 to the power x equal to 600, and here it becomes 4 to the power x. And now both of them have power x. What we can do, we can cross multiply. So let's divide this 4 to the power x here, and it becomes 5 to the power x over 4 to the power x equal to 600. So whenever two bases have same exponent, we can put them together. 5 over 4 to the power x equal to 600. And now they have suggested to use logarithm. We will use logs on both sides. Log 5 over 4, let's write it 1.25 to the power x equal to log of 600. Okay, now this x is the exponent of this 1.25. It will come and become its coefficient. X log 1.25 equal to log 600, and x equal to log 600 divided by log 1.25. And now just use your calculator to find the value of this. I'm using my own. And as usual, by the time I'm doing this, please subscribe to my channel and like and share this video with others so that they also get benefited with you, and I am motivated to make even more such videos for you. It gives me an answer of 28.667, and which is three significant figures. It will be 28.7. Move on to the B part of the same. Here it is. Solve the equation this with logs, and that's it. We have to find the value of y because y is the variable here. Here we should combine this log base 3 and log base 3 together, and then try to solve this equation. So log base 3 y square plus 11 minus log base 3 y minus 1. So I brought this to the left side and 2 goes to the right side. Since both of them have same base and they are logs and there is subtraction in between, we can combine them by this method. Y square plus 11 is the numerator and y minus 1 becomes its denominator because of this subtraction. That is the logarithmic rule, equal to 2. Now, I want to remove this log so that I can be able to solve this equation. So I will liberate y square plus 11 over y minus 1 from log, and that has an effect that this 2 becomes the exponent of the base on the other side. This 3 was the base, it becomes 3 square here. So y square plus 11 over y minus 1 equal to 9. And let's try to make it a quadratic equation here. Y square plus 11 equal to cross multiply 9y minus 9. So y square minus 9y plus 20 equal to 0. This minus 9 becomes positive. 11 plus 9 is 20. That's why it is 20 here. And this plus 9y is negative 9y. And now we will factor this again just like the previous question number 6. So minus 5y minus 4y plus 20 equal to 0. Y minus 5 minus 4. So I get y minus 4, y minus 5. And because they are equal to 0, that multiplication is equal to 0, they can individually be made equal to 0. So y equal to 4, and this gives y equal to 5. And both are positive. So we have no problem using positives with logs, but still let's check if any one of them will not make any, because logs should not have a negative inside the brackets. That's why I'm trying to check it out, and both of them will give this one positive, so no issues with both. Both are right answers. Okay, what's next? Question number 8. Okay. Mark chooses 5 people from 4 men and 4 women. Okay. And 2 children. Find the number of ways that Mark can do this if there are no restriction. Among those 5 people, whether there are men, more men, less women, more children, no children, there is no restriction. That means all of them are equal and they are 10. 4 plus 4 plus 2, 10. So we have to select 5 out of 10, and no one has a higher rank or lower rank. All are equal. That's why we can use combination, because the order is not important, which is equal to 252. Okay, what is the B part? Here is the B part. If at least 2 men are chosen, so let's see, 2 men and others, because others will be women and children, right? So 2 men, 3 men, 4 men, and 5 men. These are the possibilities, right? So others will be, if there are 2 men, there will be 3 others. 3 men, 2 others, 4, 1 and 5, 0. But the problem is 5 men are not available. We have just 4 men. That means this condition is invalid. We have just these 3 conditions. And now let's interpret them into selections. We are selecting 2 men out of 4. And we have remaining are 6. 4 plus 2, 6. 6. And we are selecting 3 out of them. Then we have 4C3 multiplied by 6C2. Then we have 4C4 and 6C1. And let's evaluate them separately, which is 120 here, 60 here, and just 6 here. So one of these combinations will work, not all of them. So when it is options among the 3, we add them. And this will be 186 combinations possible. Let's talk about the next one. If at least one man, at least one woman, and at least one child are chosen. So men, woman, child. So let's start with one man, and we need at least one of this. And so how many will be the children? 3. Do we have 3 children? No. We have 2 children. So we don't have enough children. So we'll write 2 here and 2 here. That makes it 5 choices. Right? Next, 1 man again, 3 women. Then it will be 3 child. And there is no other possibility with 1 man. So now 2 men, 1 woman, and 2 children is possible. 2 men, 2 women, 1 child. Okay, let's go to 3 men, 1 woman, and 1 child, and there is no other possibility here. These are the 5 possibilities, and we will interpret them again into the combinations, and I'll evaluate them with them. And if I again add these 5 cases, the answer is 184 combinations. Alright, next one. The following functions are defined for x is greater than 1. We have to keep in mind this one. Okay, fx is this, gx is this, find f, g, x. So this can be written as f of g of x. This can be written in this format. So let's substitute gx by its value here. So f and gx is 1 plus x square. What it means that in fx, wherever we have x's, substitute that x by 1 plus x square, because here also x has been replaced by 1 plus x square. So it will be 1 plus x square, this one, and plus 3 was extra. This x will also be replaced by 1 plus x square minus 1. 1 and minus 1 cancel, and here we get 1 plus 3, 4. So x square plus 4 over x square. That is fgx. That was fast. So let's do the next one. Find the inverse of gx. So gx was 1 plus x square. So we can write that as y equal to 1 plus x square. So now to find inverse, we always interchange x and y. So x equal to 1 plus y square, that's what it becomes now. And now we have to isolate this y to get inverse of g. So first this 1 will go here, x minus 1 equal to y square. And then because we want y, we square root both sides. So by rule, it should be y equal to square root plus and minus x minus 1, correct? But if we write plus and minus both, the graph will be something like this, which will not be 1 to 1, which will not be a function, and we can't call it an inverse function. So in that case, what do? We ignore the negative part. Only positive is written. So I will undo everything and it becomes just x minus 1. Alright, next one then. Okay, this is the do not use calculator. They have tied our hands here, so we can't use calculator. Solve the equation fx equal to gx. So fx was x plus 3 over x minus 1. That was fx. Gx is 1 plus x squared. Let me confirm once more. X plus 3. Yeah. So now we have to solve this. And for solving this, we have to first cross multiply. So x plus 3 equal to x minus 1, 1 plus x squared. So there's nothing common. We'll have to open this up. So x plus 3 equal to x plus x cube minus 1 minus x squared. When I opened this, I got these four terms. Let's put these also with the other terms. After collecting everything to the right side, what will we get? X plus x cube minus 1 minus x squared minus x minus 3, right? Alright, this x and this cancel out. So what are we left with? X cube minus x square minus 4. Okay, so this is not quadratic, so we can't factor it straight away, but we can use remainder theorem to find one of the factors. So remainder theorem, what do we do in remainder theorem? We substitute the factors of minus 4 one by one. Let me put mentally, you can use one in your calculator. So let me, what are the factors of minus 4 by the way? The factors are plus minus 1 and plus minus 2 and plus minus 4. One of them will work. Let me start with plus 1. So 1 cube minus 1 square 0 minus 4. No, it is not giving me 0. Remainder theorem should give you 0 so that it becomes a factor. So plus 1 is not a root of x cube minus x square minus 4. What are minus 1? Minus 1, this will be minus 1, minus 2, minus 6. It is also not giving. Let's go to plus 2. 8 minus 4, 4 minus 4, 0. Yes, plus 2 is working. So let me show you what I did. When x is plus 2. So this becomes 2 cube minus 2 square minus 4. This is 8, this is 4, and this is 4. That becomes 0. That means x minus 2 is a factor of the given equation, this x cube minus x square minus 4. Whenever plus 2 becomes a root, bring it to here. So it becomes x minus 2 equal to 0. That means x minus 2 becomes the factor, not x plus 2. Okay, and now we can divide it. So x needs x square to make it x cube minus 2x square. This cancels out. X square minus 4. We need x. So x square minus 2x. Cancel. And this will become plus 2x minus 4. And now I need 2. So that will become 2x minus 4. See, by getting plus 2 as a root, we got x minus 2 as a factor, and the remainder is 0 here. So confirmed. So answer here will be x minus 2, x square plus x plus 2 equal to 0. And this gives us answer x equal to 2. And for this we can use quadratic formula, but I don't think it has any root, but let me try. Minus b plus minus b square minus 4 times a times c over 2 times 1. Yes, b square minus 4ac will give you a negative number. The square root of that negative number is not possible, so that means this will not give you any solution. X plus equal to 2 is the only solution. With that good news, let's go to question number 10. Wow. They have given a graph, and what are they saying? They're saying find the equation in this format y equal to mx plus c for this particular graph at x equal to 1. All right, good. So the equation of a tangent is y minus y1 equal to mx minus x1, which is not this format, but once we get the equation, we'll convert it to this format very easily. So we need m and y1 because we don't need to find because it is already there. Our general y, this is general x. X1 is given. X1 is given as 1 here. And y1, let's find y1 first. Let's start with y1. Okay. So this is the equation of the graph or the curve. So y equal to 5 over 1 plus 1 square minus 1. I substituted x equal to 1, so I'll get y. So this and this cancel, 1 minus 1 0 is 5. Y is 5. So we got y also. Y equal to 5. What left now? M. M is nothing but dy over dx. That means we have to differentiate this equation of the curve and we'll get dy over dx. So let's differentiate 5 over x first. 5 over x can be written as 5x to the power minus 1. So when we differentiate this, this minus 1 comes and multiplies with 5. So it becomes minus 5. And this minus 1 exponent goes down by 1. So it becomes minus 2. Plus the differentiation of x square is 2x. Differentiation of minus x is minus 1. That's it, done. But we want dy over dx m when x is equal to 1. So m equal to, substitute 1 into this and this becomes the gradient of the tangent at x equal to 1. Minus 5, 1 to the power minus 2 plus 2 times 1 minus 1. So 1 to the power anything is 1, this is 1. So only minus 5 is left here because minus 5 times 1 will be minus 5 plus 2 minus 1. Minus 5 plus 2 is minus 3, minus 3 minus 1, minus 4. Got the gradient of tangent also. So we have everything here now. We can write the equation which will be y minus, what was the y1 we got? 5 equal to m we got just now minus 4 x minus 1. So y we want on one side, right? We want to isolate y, so let's put this plus 5 to the other side equal to 5 minus 4x. When minus 4 and x multiply, minus 4x. When minus 4 and minus 1 multiply, we get plus 4. So answer is y equal to minus 4x plus 9. This is the equation of tangent and the format is exactly what they want. This one has another part also, which is this. Find the area enclosed by the curve, the x-axis and the lines x equal to 1 and x equal to 3. Let's go to the drawing here. Suppose x equal to 1 is here and x equal to 3 is here. So they are saying the area enclosed by the curve, which is this, yeah, x-axis, which is this, x equal to 1 this, and x equal to 3 this. That means they are asking us to find this area, right? And for this we don't have to do something special. We just find the definite integral of this function from 1 to 3 and that will give us the area under the curve. So let me copy the equation, which is this: 5 over x plus x square minus x from 1 to 3 and dx. So 5 over x can be written as 5 1 over x dx, right? And then we write x square dx and then x dx. These limits 1 and 3 I will write later. Okay, one mistake students make is that they write 1 over x as x to the power minus 1, and then they add 1 to it and minus 1 over 1, and that becomes x power 0 over 0, and they think it is 0. No, it is not 0. Anything divided by 0 is undefined. So we cannot write this. The integration of 1 over x is ln x. And then x square will be x cube over 3 by the normal method of adding 1 to the exponent and dividing by the same exponent. Similarly here it will be x square over 2, and we will add c, and it is from 1 to 3. That becomes our definite integral. Let's substitute the values one by one. 5 ln 3 plus 3 cube over 3 minus 3 square over 2 plus c minus 5 ln 1 plus 1 cube over 3 minus 1 square over 2 plus c. Okay, so this can be written as ln 3 to the power 5, isn't it? This 5 goes and becomes the exponent, plus 27 over 3, 9, minus 3 square over 2, 9 over 2, plus c, minus this 5 also goes and becomes its power, but ln 1 is 0, so there is no advantage of making it a power, minus 1 over 3 plus half, and minus c, plus c, and negative c cancel out. This becomes ln 3 to the power 5 will be 243. Yeah. Then 9 minus 9 over 2 will be 9 over 2 again, minus 1 over 3 plus half. Okay, 9 over 2 and 1 over 2 will become 10 over 2, which is 5. So ln 243, let's separate this by bracket. 5 minus 1 over 3 will be 14. 5 times 3, 15, 15 minus 1, 14 over 3. That's it. Are they saying exact area? Exact area, yes. So this will be the exact area. Okay, let's see what is the next one. Question number 11. The volume V of a cone with the base radius of R. Okay, so let's draw a cone, and the base radius is R. Okay, and the vertical height is h, is given by this. All right, V equal to 1 over 3 pi R square h. The curved surface area is pi RL. Okay, so let's say curved surface area is pi RL. L is this length. Okay. Okay, a cone has all these characteristics. The curved surface area of the cone is 4 pi, okay, centimeter squares. Show that h square equal to this we have to write. What you see here is h is squared. That means they're talking about the area again, and we have this area here, pi RL. Let's talk about this one, okay, because they have given that is equal to 4 pi, curved surface area, pi RL. So if this is L, can I write it in terms of h and r, because that's what they want, h and r, right? So we'll do that. So by Pythagorean theorem, h square plus r square equal to L square, and if I square root, they become like this. So L is square root h square plus r square, and they gave us pi RL is equal to 4 pi. The curved surface area pi RL equal to 4 pi. First of all, let's divide both sides by pi so that we get rid of pi. There is no pi in this, so pi cancels here as well as here. Let's replace L by its own value. R, we just got L equal to h square plus r square, which is equal to 4 now. Okay, now we have to square both sides to get rid of this square root. So let's square here, it becomes r square h square plus r square, square root is gone, and it is equal to 16. And they want us to isolate h square. So this h square has to isolate. So let's remove this r square first by using word mass, right? We remove the one which is multiplying first. Gone. H square equal to, not equal to, plus r square equal to 16 over r square. And now we will isolate h square, which is 16 over r square minus r square. And I think that is the one they wanted us to show. This is the one. Okay, what next? Let's see what is next. Show that volume is equal to this, and we'll do the same thing here also. Volume formula they've given 1 over 3 pi r square h. We don't see any h here. Can you see? Only r is there. That means we have to find the relationship between h and r, and we already have it here. Can I write h equal to square root 16 over r square minus r square, right? And that's what I will use here. V equal to 1 over 3 pi r square square root 16 over r square minus r square. It is not matching fully because 1 over 3 pi is matching with pi over 3. That means this r square must go, and we can't remove it anyhow. We can take it inside the square root. So how will that happen? Equal to pi over 3. I wrote this as pi over 3 and start square root straight away. When r square goes inside, it becomes r square square. Let me try to explain it to this one. If I have 3 and I want to bring it inside a square root, what does it become? 9. 3 is square root 9. So it is squared when it went inside a square root. Similarly, when r square goes inside the square root, it will become r to the power 4. And that's what I'm going to do now. R to the power 4 multiplied by 16 over r square, which was already inside. R square was already inside. So it becomes pi over 3, and when r to the power 4 multiplied with 16 over r square, 2 of the r's will cancel out with 2 of the r to the power 4, so we'll be left with only r square, and 16 is already there, so it becomes the coefficient. Now r4 also multiplies with r square, becomes r to the power 6, and I think this is what next? This is next. Given that r can vary and v has a maximum value, we have to maximize the volume. Whenever we have to maximize a certain parameter, we will differentiate this with respect to the one that is varying. So we will differentiate this equation. Okay, so v prime, which is dv over dr, is equal to pi over 3 is a constant, so we will not touch it, and this becomes, let me write it here, this can be written as 16 r square minus r to the power 6 to the power half. This square root can be written as power half, and this is what we will differentiate. This is power of a function, and power of a function is that this half comes in front and becomes coefficient first. Then the contents do not change, but their exponent goes down by 1, which is half minus 1 here. And further, we multiply it by the differentiation of the contents. 16r squared minus r6. It will be 32r minus 6r to the power 5. This is the differentiation of the volume equation, which becomes pi over 6. And half minus 1 will be minus half, so it becomes a denominator. Let's put it down there. 16r squared minus r to the power 6 square root. Alright, and this one is what it is. So we can write it 32r minus 6r to the power 5. So This want maximum volume. So whenever there is a maximum or minimum stationary point, we have to make it equal to 0. Its rate of change equal to 0, because at that point it is turning back and becoming minimum again or maximum again. So it is equal to 0. So when I made this equal to 0, the denominator goes and multiply with 0 and becomes 0 gone. Even this 6 can go, right? So what are we left with? Pi 32r minus 6r to the power 5 equal to 0. We can even remove this pi by dividing both sides by pi. So this pi is also gone. This is still 0. Now we are left with 32r minus 6r to the power 5 equal to 0. So let's take r common here and 2 also, right? Yeah, 2 also common. 2 are common. So we are left with 16 minus 2 is out. So 3r to the power 4 equal to 0. So this can give us either 2r equal to 0, which is r equal to 0, and the radius cannot be equal to 0. So this answer is invalid. We will not accept this answer. This will give us an answer. Minus 3r to the power 4 equal to 0. 16 equal to 3r to the power 4. R to the power 4 equal to 16 divided by 3. And now find the fourth root of both sides. And this fourth root and 4 cancel out. R is equal to fourth root of 16 over 3. Are they saying exact radius? Find the value of R that gives maximum volume. They are not specifying. You can leave your answer like this or put this in a calculator and you'll get answer in decimals, which is, I'll have to use my calculator for that. And by the time I use my calculator, I would request again you to subscribe to my channel, like and share this video with your friends so that all of you get benefited, and I am overwhelmingly motivated to make many more videos like this for you in future. Thank you. So when I used my calculator, I got 1.5196, but we have to give answer in 3 significant figures, so 1.52